generative AI. So we run a GPT lab and we do research with a large language model. We also do sandboxing, experiments for companies who are interested in applying Gen AI in their business. We have research, have people work with security application of AI, like AI for SEA, SE for AI. So these are some of the books that I have on. The most recent one is this one, generative AI for software development. Currently, I have 7 PhD students and had supervised several master theses, and many of them now on language model for software engineering. Okay, I also have a long list of teaching experience, like different courses in software engineering. A recent courses on, for example, green IT, about the energy efficient and sustainable aspect in software development, and we focus more in green AI these days. And so I have another course called Advanced Software Engineering, where we look at engineering practice for developing AI systems. Also, part of several communities, research communities, taking part in journal reviews and also do guest editors. To demonstrate what we do, we have a recent prototype called Startup GPT. So we use LLMs to assist startup people, and this prototype is very well perceived by startup companies in my city. So we our plan is developed by 2 master students, and we plan to develop this further. Yeah, and yeah, turn into a startup in some point in time. And this is another one. It's called a Pro 1000 GPT, and the Pro 1000 is the name of the course. So this built as a virtual assistant for the course, and it's supposed to give more personal guidance or troubleshooting for students when they conduct their project in this course. Yeah, not yet as we expected, but yeah, we have planned to improve it in next semester. Very importantly, students have already asked it. So you write down in your note. So this is my email. If you want to ask anything, questions, or want to, if you're interested in some of our research, our lab is you have different kind of open opportunities and with different type of compensations. Yeah, so if you are interested, yeah, we can also discuss, can talk about that too. But send me email. All right. So this is about me, but I also want to understand about you as well. So we have let me see. No, I should reset this then. Okay, so you will see in my screen the Menti quiz. What you do is type menti.com in your web browser and enter this code. So a few questions to and it's important to know what you know already regarding the software engineering course and regarding this module. So I can adjust my pace and the amount of content. Okay, we have one already logged in and yeah, okay. Okay, two and keep counting. So this is a word cloud. So if the same word repeat, you will see it appear larger in size. Mm. Okay. Let's see. Yeah, pressure, depressed. Why that so? So it's a mix of both positive and negative here. Um, okay. So black meat mukong. Okay, meat is the MYTH, but not the meat here. Meats. Okay. So maybe we're having this like what is that? It's 4 p.m. right? It's late in the afternoon in Vietnam, but okay. We try to make it lively so you're not become more sleepy. Okay. Um. Now let's do a real question. Okay. I see that's a lot of energy here. Okay, let's keep coming. Um, So, so you started on the capstone project. You're working with the printing system for Backward University, right? So the question is, which tool you will use to draw the diagrams? You have done the use case diagram, and this you will continue. You will draw more diagrams, and they are UML diagrams. So the question is saying, what's your experience with that? Okay, so we have most of you using draw.io, so it's an open drawing platform. You can draw a lot of things, but basically you start from scratch. It doesn't provide you patterns, a template, right? It might, but it's not. I mean, a professional tool for system modeling. LucidChat is one of them. There's still that two people using it. But visual paradigm used to be a default software to draw UML diagrams in my time. And they have online versions as well. Net-based platform, you can register for, I think it's enough for this course. So with the trial versions. And it give you the right notations. It's kind of an industry standard notation they use. And you can also get a lot of support or tutorials as well. Uh, uh, I would recommend you to use visual paradigm for drawing diagrams. And in this lecture for during the exercise time, you will actually uh, uh, use supervised to use visual paradigm. Okay. Okay. So let's do a bit rehearsal here. As part of the milestone one, right? You draw use case diagram. So, what kind of relationship that you have used in your diagram, in your yeah, here it's a task 1.3, right? That's you do part of the requirement elicitation. So what kind of relationships that you have used? Okay. Um, how about the others? Yeah, we have I mean more than 30, I guess. So let's wait a bit. So the association is the link, right? Is the line that connect from the actor to the use case, telling that that use case have that. Sorry, telling that that actor have that use case. Um, Generalization of an actor, meaning that you have one actor that is a special type of another actor. Inclusions, I mean, you have an use case include the behaviors of another use case, right? And extensions is when you have a use case that is a special type, special have part of that is belong to another use case. And generalization, when you have one use case are a special type of another use case, right? So all of these are common possible relationships you can find in a use case diagram. So it will be not, yeah, it can be very straightforward that you use a basic one. I mean, the link between actor and use case. Yeah, we have to have it. But interesting. Yeah. And I would really encourage you to use different type of relationship here. Yeah, when you learn about use case like one. All right, let's get to the next one. So you will also have a use case description. It's usually a table where you can describe the flow. And sometimes it's not enough to have one flow, so you have an alternative flow. Login, for example, what happened when login success or when logins fail. Yeah, so we will talk a bit about this again in the lecture today, right? But it seems that this is no problem. It's most of you have alternative flow in your use case description. Let's get on to the next one. Okay, now get to some real question. Uh, hmm, hmm, hmm. Hmm. Yeah, okay, very good. I think most of you say correctly. So in this one, printer shouldn't be an actor, right? Uh, Something one is nothing wrong is actually very wrong. Yeah. So read again about the use case and what the rules apply for actors for use case. Very good. Let's move on to the next one. Um, okay, it might be challenging or not. Uh, you haven't learned about class diagram yet, but yeah, try your best. We will talk about it next week. So when we talk about class diagram, we assume that you do object-oriented programming principle, and things are presented as a class or object inside a class, and there's a certain relationships among them, right? So you have a class called students who represent for a real student, right? They have the properties and it have a behavior. And you have a printer, it also have its properties and it have its behavior, right? So what was wrong here? Hmm. Okay, anyone else? Hmm. Okay, good. Yeah. So I think probably the best one here to say that bots are not inherent types of each others, right? Are they friends? Maybe not. Let's see. All right, but then I have a last question here. Um, rate your own knowledge regarding one of these diagrams. So this is a name of different UML diagrams. And if you do system modeling or architectural design, you learn by heart. It's yeah, you cannot miss these tools for doing such a modeling task. But let's see how much you know already about this, so I can maybe I will go faster if you know more. The other way around, then we'll go a bit slower. Uh, So to prepare for this course, I will ask you to read at home the books. So the slide here built based on the software engineering book from Jan Somerville. Yeah, it's still the most classical book for this course. And many examples in this slide are from that book. And you also can do some practice at home, for example, regarding these diagrams. Uh, and I want to go a bit faster with theory part and instead doing more interactivities like this in the class. All right, but here we see the only thing that above 5, the neutral point is class diagram. You are a bit more confident with class diagram and a bit less with other type of diagrams. So it's okay, and we will learn sequence diagram today. Okay, let's get to our slides. So this week and next week we cover different type of models. We have context model, interaction, structural, behavior models, and we will talk also about model-driven engineering. So we know that what is the definition of system modeling and why we need to do that, right? Think about building a house. You usually start with a blueprint, right? Sketch the structure, the how many stories, and the appearance of the house. So we do the same when we develop our software systems. We need to and better to have an abstract representation of the software systems before start building it. And this abstract model, it means some kind of graphical representation. So everyone want to look at a chart, at the diagram, a picture, right? It's when you develop or build a house, easy to understand, easy to capture relationships among them, and to visualize some complexities. And a system model will help to communicate with customers, right, who pay for the system, to communicate with manager who manage the project, and to communicate with the builder, like developer or tester of the system, right? People say that a picture worth more than 1,000 words, right? And that's how important it is to have visual representations here. And we can model not only a new system, but also the old systems when you want to capture the current state of a systems. All right, you describe what is there, what is the problem, what missing, and that's a reason leading to building a new systems. And, like a house, when you do a blueprint, you will have many different aspects to look at. It can be the overall structure of the house, right? How many stories and how many rooms, the map of the rooms. But you can also look at the technical view in the house, how the electric systems is designed and implemented, and how the water supply line runs, right? And the same for software developments. You have different views of the system. There are no single chart or diagram that can capture all this aspect. That's why you will usually have different diagrams to represent the systems. We have a called external perspective. It's a context model. We have the interaction between a system and environment or between components of a systems. We have also a substructure of the code, the files, of data. We also have the dynamic behaviors of the system and how it responds to events. Well, yeah, and then we talk about this. And it's important to know that there's a lot of different graphical language. There are different kind of diagrams available. UML is only one of them. But this is also the most common one. And it's fair to say that you said to learn this and you can work safely in on different companies when you graduate. So the UML offer a pack of diagram, and they name, for example, activity diagrams, use case diagrams, sequence diagram, class diagram, and state diagrams. This doesn't have to match one-on-one with the system perspective, right? For example, you can use case diagram and activity diagram to capture the interaction aspect of a model. You can use case diagram again to capture the context aspect of the system. So they have they can be used in different roles, but of course, I mean they usually associate with one main aspect. For example, sequence diagram shows the interactions, activity diagram as well. Class diagram show the structure of classes in a system and the associations among them. A state diagram shows you how the system reacts to events, like the dynamic aspects. So we will talk about this and then we have a break before I get to the sequence diagram. The context model will capture the operational context of a system, and it's important because this model defines the system boundary. Usually, it related to conversation about social and organizational concerns, where it affects the decision on where to position this system boundary. You can see it from this picture, from this context model. Yeah, it doesn't. It is not part of the UML diagram. You don't have, and you don't need to use any complicated language here. You can represent it just simply like connections among the rectangle boxes. And this example is a man care system. You read more about this from Somerville's book. Yeah, but it's about the inventory in for the medicine in a hospital management system. And from this, you can see everything that besides beyond the boundary of the main system here, they be part of the context. It means that man will not do admissions. It's part of the admission system. It will not do the prescription. It will not do appointment. It will not do management of reporting or patient record, right? That's why it can stay in the context. So the process model reveal how the system being developed, right? And in the broader business process, And sometimes when you want to understand more detail, we can use a activity diagram here to capture the role of man care system in the context to a process. Right? So yeah, we develop. So here we use activity diagram, but we do not focus on the interaction aspect. But here we only want to show where is the interface of man care with the process happen in the environment. Mm, all right, and we were so you read more about example with context model, yeah, but it's as simple as that. Okay, so before I get to the interaction models, we will have a break. So as we come back at 5, right? But in the meantime, one thing I want you to do is to yeah, to log into this online.visual paradigm.com and register an account there. Okay, and I'll be back in 12 minutes. Okay. Right. Let me see. Could we continue? So before the break, we talk about context model, and yeah, it's very simple. It's a diagram of boxes, and now we talk about the interaction models. So you can do interaction model in different levels. Now, at the user level, to model the interaction among user and the big systems. At the system level, to model system to system communications, or lower at the component level to understand if a proposed system structure is likely to deliver the required performance and dependability. So they talk about two types of UML diagrams here, use case diagram and sequence diagrams. So I won't be fast with use case diagrams since you seem to know it already. So you can, for example, in my slide, I put this link. You can see like how to write a good use case name and the tips for making a good use case diagrams. This is one example of the one use case in the main care systems, and it shows the connection between medical receptionist and the use case on transfer data. Yeah, so make sure that you name on the use case as a verb or verb in phrase like transfer data, right? And here it's linked to the patient record system. Right? It's another actor here. And the medical receptionist have not only one use case, but he able to do other things as well. Register patients, unregister, view informations, and contact patients. The use case diagram usually quite brief, so you don't understand much. It shows you either whether more or less the boundary of the system. Now that's why you usually also provide use case scenario descriptions together. And here you see the tabular format where we have more structured description of the use case. And you see an example here. So this a search for club events. When you are in university, you might want to attend, participate in different club like football or kung fu or music, right? And you can search for that. So the actor is show that is anyone as a member of the public can be an actor here. As short descriptions and then the detail it show in a normal flow, exception, and alternative flows. And here the precondition, it tells you what condition need to meet before the use case can perform. For example, if you are in the e-learning system, the precondition can be that you need to be logged in to the learning portal to be able to do something there. But here, the precondition is the general, so you don't need actually any requirement here. So only need to be internet connected, right, and be in the university homepage. And here, in the normal flow, it show the interaction between the actor and the system. And you actor start with MP and system start with systems, right? 1, 3, 5 is a step. done by MP, and 246 is a step done by the system. You can make an alternative flow for the whole flow. I mean, replace the whole normal flow, or you can do by to replace to give alternative part or part of this flow, like 3A or 3B, right? Okay, and you have done that, so I will not stay too much with that. And I spend most of the time today with the sequence diagrams. And as said, it's one part of the UML diagrams used to model the interaction between, it's very common to use for actors and objects within a systems. And this is an example of a sequence diagram. We have, for instance, the actors that's represented by the users by the violet color here, and we have an object ATM, consortium, and bank, and we have the message go between them. The first message is the insert cards go from user to ATM, right? And then they have a certain time constraint, and when it's when the condition meets, the next message sent from ATM to consortium. So verify card, and from consortium it send another message to verify account to the bank. This scenario showing a failed login case. The bank see the account is information not correct. It reply usually send the flag like not okay. Consortium get that and send back a reject card, which give the action reject card from ATM, and that's hit the users. The lifeline is the dashed line here. It show you the lifetime of the object or the actor in this use case scenario. And we have also activation line. So by this rectangle, so it's power mean for you actor is the whole time is activation, right? And for ATM, you see, in the beginning, it sleep, right? ATM is inactive until they get the insert card, and then it become active. And we have also time constraint represented by this mark. And this is important. It's a message. It's message when you implement. It's actually a function call. You will implement a function and you call the ATM object, and the ATM object will also inside its class itself a function, and it will call the consortium object. Okay, and now we start this exercise. You were logged into this link that I'm giving you here, tinyurl.com/system modeling double L. Okay, system modeling BT1. We will work with the exercise here. Okay, good. So I make a page here for each of you. Yeah, student 1, student 2, student 3. So you are free to change the name here, but don't change the first 3 slides because it's the instructions. And you do draw You complete the exercise by copy and paste into this one of this page your sequence diagram. And I give an use case here. So the use case taken from smart urban waste collecting systems. So in these systems, we have different actors. We have the back office who actually just sit down and monitor a software system. We have a collector is like nhân viên lao công, right? Or là tài xế lái xe. So they are the one who actually collect the garbage. And we have what's called a major collecting point is where we something where we collecting garbage from different small points into the big point to be transferred by truck. And yeah, we also have the route. The route define how where the collector should go. Okay, so since you don't have a domain knowledge about this project, I will help you a bit. So I will provide here the definition of the actors, like the users or components, and also the message that can go in between them. Uh, so in this guideline, you yeah, it gives you a guideline to register an account and try to make a sequence diagram from their template. So your task, so you work individually, okay? So each of you will own one page in this slide, and your task is to provide your diagram here. So I give you like 20 minutes, and then I come back and I try to give you as much comment as possible. And after that, we have an open space for Q&A before we close the lecture. The link again in the comment section. Right. So this is the link. Or maybe you mean the link to this. Okay, I'll show you the slide here. So this is access to the exercise sheet. Okay, and you can ask your friends if you haven't been able to get to the page. Switch to. No, not so many. There's only 6 people here. All right. Let me see. What are you doing? I can put a link here in the chat so people, if you are online, you can join. Okay. Hmm. Okay. Well, it's like 11, 12 students, but yet not yet. I think it's a bit like 40 people in this class. So yeah, log into this link and do the exercise. Yeah, I think I have seen one. I think we have one student who complete the exercise. Very good. Uh, I'll look forward to someone else. Okay, let try like maybe in 4 or 5 minutes, and then we go through it together. So yeah, I just hurry up. Okay, we have a group of kid Nghĩa and Phú, right? Okay, 3 people. Get something. I think we have 2 more minutes. And then we can yeah we need to spend some time to correcting them. So be hurry. All right. If you still working on this, and maybe you save it as a homework, yeah, complete it, and you can still like paste in this Google Sheet. And I need to run through them now. So you have actors and several modules here. They should talk to each other, and some of the message titles is also given. Let's see. Very nice. We have the first one here. I don't know if it's correct, if because you have two back office staff, right? Why? You have back office staff and you also have back office staff. Yeah, and maybe we don't do it like this. Or maybe you can collector, right? And you can put a collector in the end. But other than that, I mean, it's yeah. Usually, when you send out a message, you expect to receive a return, right? It's like a function call. You call a function and usually it return you some value in objects, or it can be simply like a yes or no flag. So you and then here, for example, select root. It doesn't give you back anything. It's not very correct. And identify major correcting points as well. It doesn't give you any, and it's not go directly from scheduling module back office staff. But back office staff do not directly call the scheduling module, right? So I have to fix this. If one look more correct, I guess it's like you get some ChatGPT support maybe. What this look like? One thing with this model is that we overload the actor, the users here, the back office, and we have too many direct message to handle from different modules, right? Other than that, it looks correct to me. See this one. Okay, this one is nice. Matt, you have yeah, it's actually the same because you also overload the back office. Here you can for the user, you keep one activation line continuously. No, you don't have to I mean have it in a splitting like this. Yeah, you have it along. And okay, I show you my example. So I don't overload the back office staff. We assign some role, function for the area selection module. Here it will call the identification of this point directly within the area selection module, and that will go further to scheduling module, and it come back in the same way. And the back office staff only interact with the area selection module here. Yeah, and then you see some other example from other students. Okay, so if you able to create something like this, and so we get our learning objective. Very good. Now I will be back to the slide. So next week we will talk about a structural perspective and dynamic perspective, and we do class diagrams here. I don't know if you learn enough about object-oriented programming. If not, then you have to do that somehow, because class diagram is a representation of OOP. You need to understand the different concept like inheritance, right? Like properties and behaviors, right? So in order to draw a class diagram. So I will open here the semantic. for you to give some feedback or questions. If you have any question you want my answer, then put it in here. Mm, mm. Nước mắt. Okay, it's getting interesting. So yeah, really encourage you to have questions like this. Uh, I will take this one. There are many types of diagrams. So when develop a software, do we need to draw all of it? Like I said, like you when you build a house, you will draw. I mean, mm, mm, the outlook of the house, right? You draw the electricity system. You draw a water pipeline. Do we need all of that? Then, if you really build a proper house and it's also a big house, and you need all of that because not only one person, many people who will build the house. And sometimes you don't even talk to all of them. So if they see the more detail they have in these diagrams, the less mistake they can make when they build this house. So yes, so usually when you do system analysis, you will have documents with a lot of UML diagrams, from use case diagram to sequence diagram, class diagrams. All right. Let's see. I think we can wrap up for today. On Yeah, you can also send me via my email if you have further questions. And if nothing changed, then we meet you next week at the same time, and we do class diagram and state diagram. Yeah, thank you. See you.